All right, mathletes, welcome back. So let's talk about confidence intervals again. But what happens when you have two groups of data and we're going to call these paired data? And what do I mean paired data? So these are related somehow. So the way I like to think about it is like you have the same subject and you could have like a before and after. So say I'm working with a student, they take a test before I work with them. And then all of a sudden I come in and I start tutoring them and I start doing review lessons. And then they take that same test. And we say, all right, how well do they do now after the tutoring, right? It's the same person, same test, and we examine it and we take a look at the difference between the scores. Or let's say I'm looking at these 20 cars and we see how well they're doing miles per gallon wise when we look at this particular type of gas that we pump in. And we say, okay, miles per gallon, and all of a sudden we do some change. Maybe we change the gas to some high performance gasoline. And then we say, all right, now how many miles per gallon are they getting? And we see, is there a significant difference? And so I might want to see, what is the average difference between the two groups? Is there a significant difference? All right, so we're going to start looking at those ideas, just give you an idea of what we're playing around with here. All right, so let's jump in here and let's take a look at an example. All right, so breathe deeply and let's actually do this. I want to get my full screen so you can see my calculator. So you can see how to use your TI-84 or your app to run this data. All right, so breathing rates in breaths per minute were measured for a group of 10 subjects at rest and then during moderate exercise. So the results were as follows. So you have these different people, right, these subjects, and this is their breathing rates at rest and then with exercise for Jimmy. And then for Sally, at rest, it was 16, and for exercise, it was 40. And then for Jose, at rest, it was 20 breaths per minute. During exercise, it was 31 breaths per minute. So we just documented all these, right? So this is like a maybe before and then after type of deal. But notice the subject remained the same, okay? So whenever you have this type of situation where you kind of have like a before after, but you're looking at the same subject, these are called paired data, okay? So because these results are related to the same person or to the same subject, all right? So what we're gonna do is we gotta be careful. We're gonna put these in list one, list two, but when we take the difference, it usually doesn't matter, but in this situation, they're gonna be very particular in terms of how they want the difference to be expressed. So they're going to want us to construct a 99% confidence interval for the mean increase in breathing rates due to exercise. So this difference, the D, let D represent the breathing rate after exercise minus the breathing rate at rest. So we're going to do this list minus this list. And again, it doesn't matter where you put L1, L2, as long as you make sure that when you do the subtraction, if they give you instructions like they do here, we're going to put this list minus this list. All right, so let's go ahead and plug all this in. So stat edit, plug all this in. 21, let's see if I can do this with my keyboard so it's faster. 16, 20, 14, 16, 17, 19, 15, 18, and 21. And notice, you're not putting these subject numbers. These numbers don't matter. Just pretend they're names of people, all right? So that has no impact whatsoever. All right, now let's put in the exercise. So notice I'm putting it L2. You can put it wherever you want. So 31, 40, 31, 32, 33, 35, 37, 32, 35, 39. All right, notice you're getting the same number of n values for each list, right? The sample size is the same. If not, you're going to get an error. That means you forgot one. All right, now here's the part pay attention to. So in L3, notice I'm going to the top, make sure the list is highlighted. So I'll hit enter. And then I have this cursor is blinking. So now I could put the exercise list minus the rest list, but make sure you paid attention to where you put everything. So here I'm gonna put L2 minus L1. And all it did is it subtracted each of those numbers for me. All right, so there. Now we have that list that we want. So L3 here represents the difference. All right. And so now I could go ahead and run using my TI-84 calculator, I could run a confidence interval. Okay. So it's just some things to look out for. So when you're looking at this last list, you're going to want to go ahead and do a dot plot just to make sure that it's somewhat symmetric, right? There's no strong skewedness and that there's no outliers. So here we could see there are no outliers. And we're doing this because n is small, right? N is 10. All right. So we went ahead, we plugged everything into our calculator. So now we're going to go to, let's get out of here, second quit. So I'm going to go to stat. I'm going to head over to test. And remember, we're looking for a confidence level, but because we do not have a sample standard, population standard deviation, excuse me, we're going to go over and we're going to hit T interval. All right, so T interval, because we have the sample standard deviation. Notice I have in data, my final list is in second L3. So it's in L3, frequency we're hitting 1. The confidence level I'm using is 0.99 because we're 99% confident. That's how confident we want to be here. And so when I hit enter, we're going to see we're going to get 12.78 as our lower bound, and our upper bound of 20.82 if I round it. All right. And so notice it also gives me the mean, difference, and the standard deviation. All right, so what we would say is that we are 99% confident that the mean increase in breathing rate due to exercise, right? So how many beats per minute faster was your heart racing due to the exercise? Well, we're 99% confident. We're pretty darn confident that the number of beats increased between 12.782 and 20.818 beats per minute. All right. So whatever the population increase was, the average, whatever that population average increase was, it's going to fall somewhere between these two numbers here. So the next question they asked is based on the confidence interval. So now make sure we understand this. Is it reasonable to believe that the mean increase is 20 breaths per minute? All right. So what we're looking for here is whatever number they give you, you're going to ask yourself, is that 20 within these two values? And 20, yeah, 20 is at the higher end, but it is between this value, these two values. All right. So make sure you write that down. So this confidence interval does contain 20. All right. So let's see. Let me go back to the original question. And let's see what they're asking. Based on the confidence interval, is it reasonable to believe that the mean increase is 20 breaths per minute? All right. So that's what the question. So because the confidence interval does contain 20, it does not contradict the claim that the mean increase is 20 breaths per minute. So another way of saying this is that, yeah, we agree that the mean increase is 20 breaths per minute, right? We're in agreement with that because that 20 does fall within our range here. So I know it's a weird way that Alex here kind of states that, but just to highlight what is it that we found. All right. So again, what you're going to be doing, just to highlight, let's look at another problem. We won't go through it all, but just to make sure what we're looking at. So here, human skin loses water through evaporation, and in general, damaged skin loses water at a faster rate than undamaged skin. I had no idea. So in a study in which the outer layer of skin on a small section of the forearm was partially removed. Water loss in grams per meter squared per hour was measured before and after skin removal. So here's the results. So this is before and this was after, right? So before skin removal and after skin removal. So again, all we do is we're going to subtract, boom, this list minus this list. All right, so press pause and I want you to try this here. All right, so you're going to go ahead, press pause, and you're going to do the same exact thing that we just did, right? And they're telling us here that it's the water loss after skin removal minus water loss before skin removal. So try it. So this is L1, L2, but in L3, you're going to go ahead and put L2 minus L1. All right. So watch that first example again if you need to. Press pause here because I'm going to go ahead and reveal the answer. And we're using we want to construct a 98% confidence interval here. All right. So if you're back with us, if you tried it, let's see if you did it right. So again, we just check to make sure it's approximately normal. All right. So we entered everything in. Then we went stat, test, t interval. We used L3 again. This time we changed it to 98%. And this is what you should have got, right? So you should have got 3.6 and 10.2 if you were to round. All right. And so here, the dermatologist claims that the difference in water loss is 8 grams per meter per hour. Does this contradict does the confidence interval that you found here contradict this claim? So basically you're looking at that 8 and you're saying, is 8 inside of here? All right. So because 8 is inside of here, then there's no contradiction. We're in agreement. All right. All right, folks. So hopefully this is making sense here. If you have questions, let me know, and I'll talk to you very soon. Peace.